Dear students, let's discuss the process of electrolysis in some more detail, as it is a new term for you and the process is also all new. So we already discussed the electrolysis of water, while which we use some terms, the meaning of which is to be explained a little more in this video. Like we use the term electrolysis. So what is electrolysis? As I already discussed, a chemical process that takes place during the process of passing electric current through a substance in its either molten state or in its aqueous solution. It means solution in water. For example, suppose NaCl. We pass electric current through NaCl. Then we won't be able to pass it through dry state. And even if we do, it won't be said to be electrolysis. So electrolysis will happen when NaCl is heated at its melting point so that it is in molten state. Or we can also do electrolysis of sodium chloride when it is in aqueous solution form. So either dissolve the NaCl, sodium chloride or common salt in water, or you heat it to melt. Then electric current can pass through it to bring some chemical change, and the process will be said to be electrolysis. So electrolysis is the chemical process or a process during which chemical change takes place in a compound when current is passed through it in either its molten state or in its aqueous solution. Understood? Then the next term is electrolytes. The substances through which we can pass the electric current in its molten state or in its aqueous state. They are said to be electrolyte. Right now I discussed NaCl. It can be aqueous solution of H2SO4, or it can be some other, it means simply acids, bases and salts. The reason is that electrolytes are those substances which either in their molten state or in their aqueous solution state gives free radical to carry the charge from one to other electrode. As you know, in the outer circle, current is carried through a wire, and wire is made up of a metal which is a good conductor of electricity like copper. So current can be passed through metals like copper, and that's why wires are made up of copper. But how in the electrolyte, inside the electrolytic cell, the term we use, the utensil or the apparatus through which current passes is said to be electrolytic cell. How the current through the electrolyte will pass? That will pass with the help of free ions or radicals. And how the ions will become free? If the substance is an acid or base or salt, it means it is an ionic compound. It means electrolytes are ionic compounds through which in their molten or aqueous solution in these two states, these acids, bases and salts or ionic compounds have free ions. I was saying that current cannot pass through solid NaCl because in solid NaCl sodium ion are compactly, very strongly combined, and they are not separated. As they are not separated, so current cannot pass. But if NaCl is in molten form or if it is in aqueous solution form, then it is in the form of free sodium ion and free chloride ion. And dissolution of a salt or acid or base in water therefore is a reversible reaction. Sodium chloride will dissociate into sodium and chloride ion, and sodium chloride ion again will combine to form NaCl. So electrolytes are those substances, or you can say ionic compounds. Why we say ionic compound? Because from covalently bonded compound, even in their aqueous state, free ions are not there. Take example of petrol. Petrol is a liquid, but it does not have free ions. It is a covalently bonded compound. Take example of sugar. It is, as you know, C12H22O11. Sugar. But sugar neither in its molten form nor in its solution in water. It will not have free ions, and without free ions, current cannot be carried. So petrol, sugar, glucose and other organic compounds are example of those substances through which current cannot pass. Such substances are said to be non-electrolytes. It means in molten form or in aqueous solution form, not that every compound or every substance can allow the passage of electric current. Only those substances which can give free ions in that form will be able to pass electric current through it. So electrolytes are ionic compounds which in their molten or in aqueous solution state have free radicals, and that's why they allow passage of electric current through them. Whereas non-electrolyte are those substances which neither in their solid nor in their liquid form allow passage of electric current through them because of lack of free radicals. Now, we discuss electrolytes and we discuss non-electrolyte. But even electrolytes are of two types: strong electrolytes and weak electrolytes. Just like acids are strong acids and weak acids, alkalis are strong bases and weak acids. In the same way, electrolytes are also strong electrolytes and weak electrolytes. Strong electrolytes are solution of strong acids, strong bases and salts of strong acids or strong base. This is because strong acid, strong bases and salts of strong acid or strong base, they dissociate a lot in their aqueous solution to give plenty of free radicals. As they have plenty of free radical, so they allow free flow of electric current through them. It means current flows don't just flow through it, but it also passes through it very easily with very less resistance from it. So such electrolyte which have plenty of free ions are said to be strong electrolyte, and examples are strong acid like HCl, strong bases like NaOH and salts of strong acid and base like NaCl. Such substances which give plenty of free radicals in their aqueous solution and allow passage of electric current through them very smoothly and easily, they are said to be strong electrolytes. Whereas weak electrolytes are just opposite of strong electrolytes. In weak electrolytes, the current passes through them but not so easily because they furnish or give very less free radicals in their aqueous solution or in their molten form. Obviously, the example of weak electrolytes will be weak acids like acetic acid and weak bases like ammonium hydroxide and salts of weak acid and base like like CH3COO that is ammonium acetate. Ammonium from a weak base, acetate from a weak acid, and therefore the salt of such weak acid and weak base also will be weak electrolyte because they dissociate less and therefore they give less number of free ions or radicals. If you find the terms very new and difficult, you must see the video second time again. Let's come to another term, electrode. We discussed that a bar or rod of metal through which current passes into the liquid, like in the case of electrolysis of water, they were connected in the outer circle to battery. So the rods of metal or plates of metal, and for exception it may be of a non-metal which is a good conductor, that is graphite as well. Otherwise the bar or of rod of metals and graphite for exception, through which current is passed through a liquid in the electrolytic cell, is said to be electrode. We have already discussed that the electrode connected to negative terminal of battery becomes negatively charged and is said to be cathode, whereas electrode connected to positive terminal of battery is said to be anode. So what is the difference between cathode and anode? Cathode is connected to negative terminal, whereas anode is connected to positive terminal. Terminal of what? Battery. And therefore cathode is negatively charged and anode is positively charged. Then as cathode is negatively charged, so positively charged ion which ions are positively charged? With positive ion, they are also called by the name cation. Positively charged ion or cation are deposited over here, whereas anions or negatively charged ions are deposited here. Otherwise, cathode and anode can be made up of same material, same shape, same size, but the difference is of connectivity. Cathode is connected to the negative terminal of battery and anode is connected to the positive terminal of battery. As a result, cathode becomes negatively charged, anode becomes positively charged. Being attraction between opposite charges, cations come and discharge over cathode and anions come and discharge over anode. Let's come to ions. Ions, as you already know, are of two types, cations and anions. So cations are positively charged and anions are negatively charged. And as already told, cations move towards cathode and anions move towards anode. And you already know anode means positively charged electrode and cathode means negatively charged electrode. And what is left then? Electrolytic cell. We already discussed that the apparatus through which in which the electrolyte is filled, electrodes are inserted, and process of electrolysis is done. That apparatus is said to be electrolytic cell. That's all.